So I'm Ramnivas, and I'm going to talk about kind of going into details of what is model context protocol. We're kind of going to understand why this protocol exists, and kind of go into fairly details in case you want to implement your own protocol, your own MCP server. How would you go about doing it? So a bit about myself. I'm co-founder of a company called Exograph, and Exograph is is a backend as a service. Started as a backend as a service, but recently we started to support my MCP protocol. So that's where I'm excited, and that's where the experience comes from. I started Spring Framework as well as Cloud Foundry back in the days. Those who were using anyone use Spring Framework? Oh, there are a few. All right, so yeah, aspect-oriented programming and all that stuff. In fact, I wrote this book called Aspect Chain Action. All right, thank you. I hope you liked it. All right, thank you. And I'm also into Indian classical music. So if you guys want to talk to me about Indian classical music, please be aware I may not able to stop talking about it. So careful. All right, so let's first address this elephant in the room. Like, why do we even need MCP? Right? Why do we even care about, like, because we already got so many protocols, REST protocol, graphical protocol. Why do we need one more protocol? And so to do that, we need to kind of look at what kind of interactions we're going to do with LLM, right? So for example, if you want to ask this question, what's the difference between a fixed rate and adjustable rate mortgage? We expect LLMs to be able to answer this question without much help, right? So we kind of like go ask this question to LLM, and LLM should come back with some sort of reasonable answer, such as this is the difference between fixed rate and adjustable rate mortgage. Great. What if you ask this question, according to Wells Fargo's current mortgage guidelines, what are the DTI, debt to income ratio requirement for a jumbo loan? Now we're trying to be very specific here, right? The Wells Fargo's information may not be available outside. It may be private information. So we kind of have to, if we ask this question to LLM, plain LLM, it may not be able to answer. It doesn't know it, right? So what we can do is we can sort of change the structure to say, well, we'll ask question to some system, and that system is going to go and talk to some sources such as a web page, or it can talk to a database and get that information. And it will look at the query and saying, okay, if this is the query, what are the relevant documents? What are the documents that I can help LLM put into context, and therefore it can answer based on the query and those documents. So it's going to say, pass on the prompt, along with, however, some extracted information, some retrieved information from these document sources. And then it will probably come back with saying, okay, this is the information. And this is, of course, retrieval augmented generation, right? So you are retrieving some information, augmenting your query with that information, and then asking it to do generation. This is good, right? We so now made LLM aware of it, pre-aware of something, right? We had to figure it out. What's the query? What are the relevant documents? Give it to LLM, and LLM then can do the job. Now we kind of go a step further, and we say, okay, given this user's financial profile and current market rates, find best mortgage options across 5 lenders, simulate monthly payments, and generate a PDF summary. This is the example you would have loved as well, right? This is fairly complex, right? And why is it complex? Because RAG cannot do a good job here. Why so? Because we don't know what financial information means, right? So if somebody's making $1 million a year, you may not need to know about assets and other information. Whereas somebody's making a lot less, then you have to say, okay, what is your credit history, all that. Then current market rate depends on what that person is, like, is it qualifying for certain kind of loans, and then you can get them. And then you have to say, go find from 5 best lenders. There are like hundreds and thousands of lenders, right? You cannot retrieve document from each of them and put it in the context. And then finally you have to say, okay, get a PDF summary. So this is a specific job that you probably want it to be handled in some specific format. So that's also very difficult for LLM to guide to say, please generate a PDF in this particular form. So what we do here is then we change the structure a little bit, and we say we put some system in between, still LLM, of course. We still may have our sources, data sources, web sources, etc. And we pass the query as is, except we kind of give additional tools to it. So we are saying, okay, if you need to know the current mortgage rate of a particular company, this is the API you shall use. If you want to know financial information of that person, then this is the API you can use. If you want to generate PDF, this is the tool. And then LLM will call whatever tool it feels like. LLM will understand like, okay, here are the supportive structure I have available, and I can make use of those as needed. So it might go and say, okay, get me financial information for the user, which might hit database. Then it might go and hit web pages to get mortgage rates for certain lenders. And then it will go and get the PDF finally. So this is what is called tool calling, right? So essentially you are saying LLM, fortify LLM with some additional structure, and then that LLM will use it as it needs. So you might be wondering, like, how does it actually kind of work at LLM level? So this is a very good diagram. So this is for Gemini, but it really works for every single LLM. So what you do first is you make a call to say, okay, here is a prompt, and you give function. So this is your current query and your tool descriptions. And then LLM might say like, oh, you know what, I already know the answer. I can just return the answer. Or it might call some tool, and then application will execute those tools, give that information with the result. And then it will kind of go back and forth like this. It might call more tools, or whenever it has sufficient information, it will return with the answer. Let's go details now. Like, how does it look when you want to execute it, how does it look? So in this case, I'm using example from Sonnet, Claude's APIs, Anthropic's APIs. So in this case, for example, you want to ask, what's the weather in California? So what you're going to do is when you make the API call, you're going to give that prompt, original prompt, as well as bunch of tools. So in this case, you are going to say, I have tool called get weather, and it has a description, get the weather for a given city. And you are going to say that there is an input schema. So if you want to invoke this get weather, you have to pass latitude and longitude, and they themselves carry some description. And then if you ask this question, it's going to come back and saying, okay, I'm going to, so what happens, right? When you, like, for example, do ChatGPT or you do Claude and you start to ask questions, what goes on the wire? So if you look at it, we'll start with saying, okay, I'm going to start some message start, and it's going to come with like some initial kind of like blurb, like I'll check weather for Fremont City for you, etc. That's what you typically see. Then it's going to say, let me kind of take a step back, and it's going to say, I'm going to stop now because I did my initial part. I'm stopping because I need to invoke a tool. So it then gives, again, what is going on is a wire protocol, some JSON moving between your LLM and your client. And then it's going to say, okay, I want to invoke tool. The tool name is get weather, and I'm going to pass it latitude and longitude. This is for Fremont. And then it's going to say, okay, that part is also done. That means all the information that is needed to execute tool has been supplied to the application. Then application is going to go execute the tool, and it's going to, for example, go talk to some weather API and going to give back the information such as here's the temperature, wind speed, and so on. I'll actually give a demo of this later. And then now LLM knows that the original query was, what's the weather like? And here is the actual weather information, and it can now go and form saying, all right, the weather in Fremont is currently sunny, and so on and on. All right, so that's how it works. Essentially, it's sort of LLM knows its general knowledge. In fact, in this case, notice you gave Fremont, California. LLM figured out on its own, I mean, based on its prior training, that Fremont's coordinates, latitude, longitudes are so and so. So you kind of, LLM uses its own knowledge. LLM uses the information that is supplied by the tool to kind of give you the answer back. So at this point, you may be wondering, this is talk about MCP. Why are you talking about tools, right? That too in so much detail. What does MCP have to do with tools? Well, it turns out a lot. So what is the problem is, when you look at the APIs for each of the providers, so if you look at Anthropic, the way you provide your input schema and the function call is this way. You have name, description, and input schema. If you look at OpenAI, they say you have to declare that it's a function call and the name, description, and parameters. So there's a big difference. If you look at Google's API, Gemini, then there is even different. It is a function declaration, name, description, and parameters. So every LLM provider is using a different API that you kind of have to deal with it. So as a result, you have like bunch of these providers, Anthropic, OpenAI, Gemini, and many others. And you have these services such as weather service. And that weather service has to worry about like how does it going to describe itself to each of these tools, right? It has to particularly format in a certain way. And then you have data access, Google Calendar, and so on, a bunch of other services. Each of them has to worry about each of the LLM that it wants to support. And this is a classic M by N problem that we see in many places. And this is why classically you end up coming with some sort of protocol, like USB, what you mentioned, is the same idea, right? In USB protocol, the printer works the same way as my laptop. And the way it works is like, look, it declares like I'm a printer, so I can provide you certain services, and this is how you shall use me. And then the host will go and invoke that protocol, particular protocol, sub protocol. So now with MCP, what you do is each tool, each service only worries about how to provide the MCP protocol. And we'll talk about what does that exactly means. And the LLMs need to understand the LLM protocol, typically through some sort of proxy. And therefore, it kind of opens up lots of ideas in terms of marketplace and app store. That's why the tool calling has existed for a while. It's not a new idea, a year and a half at least, if I remember correctly. But many people didn't use it because, again, do you want to write for OpenAI? Do you want to write for Gemini? Do you want to write for Anthropic? Same problem, right? So, and the same thing happens on the client side. So, client now you can plug it into some AI desktop or a cursor or Windsurf, and you don't have to worry about it in terms of particular tool or particular protocol or particular LLM. And let's say somehow we say, all right, we'll write some bridge code, etc., and we'll make it work. You still have to worry about like, how about user consent? Like, if you want to invoke a tool, for example, it wants to say, okay, let me do your financial planning, and then says, okay, I need to go and access your bank information. Would you just let it go, or would you want to like, have some control over it? How do you access network tools? Can you just go and connect it, or do you need some permission? Authentication, authorization, all these tool concerns exist when you want to work on some real applications. And that's where the MCP comes into picture. So let me give you a quick demo. This is using Exograph, but later on the talk is going to be mostly about generic tools. So let me start Claude. So quick about Exograph. So Exograph actually, the talk earlier mentioned about like, one of the things that they provide is access to data sources, right? So Postgres or Snowflake. And the issue becomes like, okay, that's great. You can have you can have an MCP server that can talk SQL and can give you access to your data sources by making SQL queries, forming SQL queries, executing them, and getting you the result. But what about security and access control and authentication, all that stuff, right? That is still up to you. And this is where the Exograph comes into picture. What Exograph allows you to do is it allows you to express your types and access control. In this case, access control is just literally true, but you can have access control that says, okay, role must be certain things, or this particular album should have relation with the store manager, and so on. So this is like a whole language, and I won't go into detail. That may be for another talk. And once you do that, you start the server. So in this case, I'm starting a server saying, okay, enable the MCP API, give it the data source, and then start the server. And it will give you a GraphQL API, it will give you MCP API, and it will give you a playground to if you want to go execute queries. But in this case, I'm going to actually use Claude. So in this case, what I want to do is the example I showed is a very standard Postgres database called Chinook, which is a music store database. So it has employees, it has albums, and you can now want to talk to that database. You can talk to the MCP. And now what I've done is, I enabled, so I can ask questions such as, which employees work at this music store? And in Claude, I have already configured like it is a Chinook data, their music store, and then it will go and talk to that store. And let's try it out. All right, so it's basically what it did is it formed a GraphQL query. This tool uses MCP, but underneath protocol is GraphQL. And that's the details though. But now in this case, it's going to say, okay, it made the query, and then it's going to say, all right, these are the people working, 8 employees. This guy is the management, sales team, IT department, and so on. I can also ask like, what kind of music you carry. let's see, what is it? It should make some sort of query to say, get me album information. So, and then it's making more queries. So it doesn't have to have one tool call, but it can do it, and it can say, all right, there are like rock music with about 12, almost 1300 tracks, and Latin music with almost 600 tracks, and so on. So what it is able to do is it is able to talk to the Postgres database. Right now, I don't show the access control access, but by the way, if you're using Postgres and you want to know, like one of the demo that this is already being used in production. Unfortunately, I cannot show that stuff in public because this is like what's very specific private data, but I am allowed to show it in privately. So if you want to see that demo, and these guys, when I showed it to, when they started to use it, they're like jaw dropped. I mean, literally, because this is an ad agency, Amazon. They help with Amazon sellers optimize their ad spending, and they were doing it manually, like looking at the track analytics information and kind of making recommendation. But when they plugged into this MCP, they just LLM just did the job, and it's like, oh my god, what we were wasting our time. So that's sort of like epiphany, if you will, people get out of using MCP. So I won't talk pretty much anything about Exograph itself. If you want to know, go to the exograph.dev, talk to me, send me email, and we can do all that stuff. So let's talk about proper model context protocol. So what is it? It's unified protocol mechanism for tool calling and more. So mostly we are going to focus on tool calling, but I will talk about other parts of MCP that are actually quite interesting. It's just they haven't gotten as much attention. So it is actually backing from all LM vendors. It started by Anthropic people, but now everybody, Google is supporting it, Anthropic is supporting, of course, OpenAI, everybody, every LLM vendor is supporting MCP. It is supported in pretty much all clients, various level of support, but nevertheless, Cloud Desktop, the example I showed you, Cursor, Windsurf, you can write your own client application. And there is actually MCP server for everything, right? There's a GitHub, Notion, AWS, Kubernetes, everything. So there's an MCP server for everything. That is the way mechanism by which your LLM can now talk to those services. So what does this protocol look like? All right. So at the core, the protocol is all about JSON RPC. How many of people are familiar with JSON RPC? Yeah, I actually wasn't familiar with it until very recently, like a year back or so, when I started to work on LSP, language server protocol. So language server protocol is something that when you do code completion or your IDE talks and IDE does give the feedback, that's the LSP protocol. And the LSP protocol also uses JSON RPC. So I had to actually implement JSON LSP for Exograph, and that's when I started like, oh, this is interesting. This is actually very, very old protocol, like 15 years back. In fact, if you look at their website, even the site itself says that it's very old protocol. It's extremely basic site. And this protocol itself is basic. Literally, you can understand in 5 minutes. In fact, this is all there is to. You make a call by saying, okay, here is a version JSON RPC, method is add, and give parameters X and Y and some ID. So if you give ID, then the response should get back result, and it gives back ID, matching ID. If you did not give ID, it's considered notification. That means it's one way. So you just notify saying, okay, I don't want to know the response, but here is some information that you should be aware of. And that's it. That's the JSON RPC protocol. So the way the players are laid out is there's an LLM, of course. There is an MCP client like Claude or Cursor, and there's an MCP, bunch of MCP servers that you may have. So the way it happens is as soon as client comes up, as soon as Claude, I started Claude, it's going to say, I have these capabilities. So I am able to go deal with tools. I'm able to deal with sampling. There are a bunch of MCP protocol possibilities. It will declare that I am able to deal with these. And then the MCP server will say, and these are my capabilities. So I can provide you tools, I can provide you prompts, I can provide you resources. We'll talk about all those details later, but essentially this is just like get to know each other. Like I can do this, you can do this, great. We'll now explore each other's usefulness. So then it will, based on whatever MCP server returns, say MCP server says like, oh, I can support tools. It says, like, well, what are those tools? And that's where the names and description and the schema comes into picture, right? That's the one, the tool calling, the details I showed you. And then it will say, all right, here are tools. So I got weather tools, and I got, who knows, get stock market tool or get web search tool, whatever tools that may be appropriate. And now comes the user, and user now wants to, of course, do very simple stuff like, help me plan a picnic, right? And then it's going to say, all right, help me plan a picnic. And remember the picture I showed you, right? You pass on the query as is along with a bunch of tools. So in this case, you are saying, going to say, help me plan a picnic, and I have the tool called get weather and so on. It's going to say, all right, that sounds great. I am going to get weather for the latitude and longitude. And then it's going to come to MCP server, and MCP server will go talk to weather service and saying, here is a weather report. And then LLM server will say, all right, now that I weather report and I have the original query, I can go and respond by saying, how about playing volleyball if it is sunny outside, but not too hot. So this is the collaboration between server, client, and LLM, right? So very short, declare each other's capability and then use those capabilities to do whatever job is expected to be done. All right. So now let's talk about the details of each of those lines, right? So initially, as soon as the request comes, so it says like, all right, I'm initializing. So client is going to say to server, I'm initializing. By the way, just let me take a step back and make something clear. LLM can never directly talk to your MCP server. It is always through the MCP client, right? So I may use a word such as LLM invokes MCP server, right? What I mean is it through the client, it invokes it. And because of through the client, that's an important thing where you can now ask questions such as, okay, is it okay to invoke this tool? You can do all sorts of things. Like client can decide how interesting this application is or whatever other rules may be, it can enforce those rules. So nothing will happen without user consent by default. No, through the client. So that's why the client is sitting in between always, right? So it will effectively as if LLM calls the MCP server, but MCP server, LLMs don't know about MCP server. They only know because through the client, because client is talking to them.
LLM is the prime, the agent as a tool is the muscle which executes the command or the function calling the parameters, right? I think the OpenAI introduced the function calling, and that was not there before that.
Exactly. So tool calling existed then, but tool calling even then, whoever was invoking the LLM call was responsible for executing the tool calls as well. So you had to write some Python code or JavaScript code to say, okay, LLM will indicate you back like, hey, I need to invoke this tool, and you had to do it in a language specific manner. MCP has kind of elevated that to protocol. So from language implementation, it has elevated to protocol. So what is happening now is it basically says, okay, this is my protocol version that I support, and my client information is this, like I'm a Cloud AI or I'm a Cursor, etc. And then server is response saying, okay, I can support tools, right? By saying tools. Now tools itself can have additional parameters such as support changes of tools and so on, but we won't go into those details. Let's actually go and look at some code. Normally I would actually write this code like from scratch, but because it's MCP server, MCP protocol itself is very easy. But to save time, I'm just kind of like rewrote it. So what is happening is this is just a simple Java class, no Spring, no nothing, simple Java class that essentially reading line from your standard in and writing to standard out. So one of the transport it supports, MCP support, is STDIO, and the other one is HTTP. SSC was a transport, but now HTTP with streaming. Again, we'll talk about that later. So what is happening is it's reading line by line. It's essentially creating a scanner for a string input. It's saying, okay, let me read it, and if it has a key, then if it doesn't have key, we don't support notifications, so we'll just continue. But if it does have it, then we'll say, okay, what is the method? So remember the JSON RPC pass method. So in this case, method could be initialize or tool list or tool call. And then based on that method, you go and do the stuff. And then when you get back response, so in this case, you're going to get result by that invocation, that method. We'll come to that in a second, but create a return response saying, okay, here is a JSON RPC, the ID that you read from the input, and then you return the result, right? So that's a very simple protocol. You read the JSON input payload, figure out what is the method, pass it on to some executor, get the response, and put it back into JSON RPC. Okay, so handle initialize looks this way. It says, okay, I'm going to create this JSON payload, which essentially the what I showed you on the slide. You need to form this JSON RPC. So this is how you do it. You form that JSON RPC, just a little bit different, complicated way, but it's really ultimately I could have written a JSON string for all I care. And then, so all right, so it knows that it supports tool, and then it says, okay, I see you support tools. Okay, but what are those tools? And then it says, okay, I'm going to invoke a method. Now this is from client to server. It says, give me the list. So this is the method, right? It doesn't take any parameters, so that's great. So what then happens? So backend, it says, all right, I'm going to, when you ask me to say, get me to list, I'm going to give you this JSON payload, this JSON, right? So the name, description, and the input schema. So you return this, you work through, I mean, obviously, like when you write real code, you probably will use some sort of Spring AI or something to make this much more easy. But I kind of wanted to show that at a raw level, what happens. So you form this JSON and return it, and then same thing, it puts it back into payload and returns it, great. So that's a JSON schema. There is no output schema except the version that was released like 5 days back or something has now optional output schema, right? So, but client support isn't there yet. So, but eventually you will see the use for that. Right now, let's assume that there is no output schema, and it's not that immediately useful unless like all the ecosystem comes around it. All right, so let's go back, and then now LLM knows like, okay, here are the tool available, weather tool is available, and this is how it should be invoked. Now the question comes like, okay, what's the weather like, or help me plan a picnic. And then it's going to say, LLM is going to now make a call. The LLM is going to say, return the response somewhere saying, okay, get weather given this latitude and longitude. And then it's going to, the MCP server is going to return a response that says, here is the weather. How do I do this in code? So in this case, I'm actually using this open weather service called Open Meteo, and I pass it the latitude longitude. Don't do this way. This is not how you're supposed to do. You're supposed to string, not to string interpolation, but nevertheless, I'll do it here between friends. Doesn't matter, right? So all right. So you basically get the parameters, and that's from parameter you extract latitude and longitude, and then you make a call, and then you form the body, and again you return here content, type is text, and is it an error? It's not, and then you return back a response. So this is the invocation that happens. So let me run that code for you. So I'm going to show two parts to it. One, I'm actually running this server. This is just a Java code, so I'm just going to build it, run it. And then there is a tool called MCP inspector, sort of playground. So let it start. So all right, it started. And now, so this MCP inspector is just essentially you can go and manually invoke it, right? There's no LLM involved. So typically during development, if you want to say, okay, is my tool behaving the way it should be? So now you can say, okay, and then you can see the interaction. It's the same thing I showed you. And then say, okay, list tools. There's a get weather tool available, and I'm going to give some latitude. I don't know which. Where is this? Maybe I don't know. Latitude 0. Let's change something to what is happening. Some place somewhere, and it's going to come back and saying, okay, this is all the information like your current temperature, hourly temperature, and so on, right? So this is whatever our API invocation did. Let's talk to Claude and see what Claude does. So what I'm going to do is let me shut down Claude. So this is the configuration to make Claude aware of this is nothing special. It's saying like invoke Java will along with this particular parameter, nothing special really. So let's do that and let's start Claude again. And now I can ask questions such as, I may consider it, even if I said didn't consider whether it might invoke it, but it's like, it's a probabilistic thing anyway, LLM. So I'm just being a bit conservative and saying, asking it and saying, all right, it's going to invoke that tool, get weather tool with latitude, longitude. And it got back the response. This is talking to my MCP server, Java MCP server that I just wrote. And then it's going to say, okay, the looks great. You can do hiking, cycling to Coyote Hills Regional Park. Anybody from Fremont? Is this legit? Okay, great. Yeah.
Cloud is talking directly to your server, or it is still involving an LLM?
So the way it happens is Claude is talking to your LLM as well as it is capable of talking to the MCP server. So first is going to call is going to go to LLM because you're talking to whenever you talk to Claude, it always goes to LLM first. Then LLM is going to respond to the client that, hey, I need to invoke this tool. Right. So it's going to say, I need to invoke get weather with this latitude and longitude. Then Claude is going to say, all right, let me call the MCP server with that tool and those parameters. It's going to return that information. It's going to pass that information to LLM, saying, I asked you this question, now I'm giving you this information. And then LLM is going to say with the Coyote Hill and all that stuff, right? So it's a back and forth between these three entities.
So it still follows that React pattern, right? The React pattern which all these frameworks
Yeah.
facilitate.
Yep. Yep. It's in the end tool calling, right? It's just like it's happening at a protocol level where you get the freedom. So there are other parts of protocols. So there's a prompt, resources, and we'll talk about some of those. So prompt is sort of pre-filled template. So you can say, and this Claude Code doesn't support it yet, but it will start to support it soon, I hear. So you're essentially saying, rather than describing all that information, I can say /generate a picnic plan. And it will come back with saying, maybe ask a question such as what's the city and what kind of people you want to hang out with for this picnic. And it will come back and then it may then say, okay, please generate a picnic plan for Fremont for non-work friend list. And then it will essentially this is LLM is not really involved. It's more like MCP server saying, I can give you expansion of sorts rather than you have to do all the work. I'll skip the details part. Like it is essentially follows the same RPC pattern. So resources is one way to say, okay, what if MCP server knows about like certain resources, in the sense some additional information, such as you may already have information about picnic spots in particular place. You can give that information to LLM. So you can say, okay, I can return that information and then it will go and use that information to pass it along to LLM, and LLM can take the information and do something with it. I do want to talk about some of the other ones like sampling. This is like interesting capability that is not yet explored, but I think it will be explored and seen much soon, quite soon. Let me actually sort of give an example. Let's say this is one thing I'm working. I said I won't talk much about Excel, but here I am. Can't stop. So this is something I'm working on right now. what we want is into exograph. Right now, the way you do exograph, initially you just write the code. We also can import from database schema. But sometimes you want to say, I'm starting a project from scratch, and I want you to create, LLM to create a model, an exograph model, right? So now exograph, I can write an exograph MCP server. So what will happen is, I can go back to like our interaction saying, okay, I'm going to ask the client or the user is going to ask, create exograph model for a Slack clone. This is the project I want to work on. It's going to say, all right, here is a model and I have tools. This MCP server, exograph MCP server is going to provide tools such as create model, fix errors, create seed data, and so on. LLM is going to say to through client to MCP server, like, okay, hey, create me model for that particular prompt, right? What is MCP server going to do? This is not one of those I can make an API call, I can calculate numbers, add to numbers, right? This is not an easy task, right? It requires understand what Slack even means, what a Slack clone means, what exograph means, and so on and on. So what it needs is, of course, the power of LLM, right? So there are two choices. One, this MCP server itself could be backed by an LLM. That would be a legitimate choice. Or, and that's an example where LLM servers were backed by, in her examples, backed by LLMs, agents. So here you can say, you know what? Actually, I already have an LLM that client is talking to. Why don't I ask saying, okay, do the sampling. Sampling is, by the way, poor word. When I first heard the name, I did not know what that meant. And Anthropic guys are also saying like, yeah, it's not the right name, but here we are, right? So now it says like, okay, exograph language is defined as this. So this server knows about what exograph even means, and then it will pass on the prompt, and then it will go to LLM. Now LLM knows about the language definition, like exograph should have this model and access control and so on and on. It knows about what Slack means from its general knowledge, and then it's going to go and generate code. And then it, based on generate code, there may be issues, and then if there are issues, it's going to go back and saying fix errors, and it will go back and forth between LLM and the client. So just to kind of summarize, sampling is a mechanism by which you get to use the LLM used by the client rather than bringing your own. Again, I will skip the protocol details. Just speaking about sampling, there's one more one more capability is coming. Actually, that is part of the one that was released 5 days back or so, called elicitation. So one thing is like, suppose let's say imagine you are doing a Kubernetes MCP server, right? And you kind of want to say, okay, spawn new nodes, shut down nodes, delete these resources, and so on, right? Whatever typical Kubernetes cluster stuff, right? Now you can ask like, hey, I want to scale up this or scale down this particular cluster, right? Here's the thing, right? Ultimately LLMs are a stochastic model, right? LLMs can do whatever they feel like. There's no guarantee. Even you may prompt, you may like beg it like as much as heavily as you want, like please don't delete this particular file system without asking me. But there's no guarantee, right? Prompt, even if you put in prompt, the LLM can simply say like, yep, delete the file system, right? So what elicitation allows you to do is it allows MCP server to ask back to client and saying, is it okay to delete this particular cluster or this particular file system? So, and therefore, you are kind of moving from stochastic model to deterministic model when it needs. So, kind of trying to bridge this world where our expectations are more deterministic, whereas LLMs are much more stochastic. All right, so last thing I want to talk about is the transport. So STDI was extremely simple, and this is what most servers support right away, is you read it from standard in, you write to standard out, and if you want to log errors, you write to standard error. Very, very simple. I read this code and I really tried to find who said this, but I couldn't. Like all the latest technologies are at least 30 years old, right? Anyone remember CGI bin, CGI Perl, that sort of stuff? Oh, okay, yeah. There are old people like me, I suppose, yeah. So what was CGI Perl doing, right? It says initially that you are going to just write to standard in and standard out. So you write a Perl script or Perl for whatever reason was so popular, but you could have done it in any language, C, C++. You read it from standard in, that's your form input. You write your HTML or to a standard out. That's it. That was the protocol, right? And you start a process, and MCP server does identical thing. It starts the sponsor process, writes to standard in whatever the question it wants to add, and reads it from standard out, and that's the protocol, right? Of course, this is useful for like if you want to do something locally, but if you want to go further, then you have to like put it remotely, and therefore the next kind of transport is streamable HTTP. It used to be SSC protocol, and the SSC protocol has been now deprecated. So what you use instead is it's very similar thing, but HTTP. So what it allows you, SSC forced statefulness on the server, and that was like those kind of servers are very difficult to write, difficult to scale. But with the streamable HTTP, like for example, Exograph doesn't support the streaming aspect of it, just the HTTP aspect of it, and that's okay. That's okay with this new transport mechanism. So last thing I want to talk about is it's a very changing landscape. So I already mentioned like how when I'll talk about only one aspect called authentication authorization. So first version was there was no auth support. So you had to bring in some ad hoc mechanism, pass in environment variable, VGLB token or whatever. It was like wild west, right? And everybody was doing everything that you can imagine, and everything was not quite right. We did it too, right? Because that's if that's mechanism available, that's the mechanism available. Then in the March version, they came with OAuth as a way to support it, but they kind of went a little bit too far and said OAuth, when you use OAuth, the MCP server will act as both authorization server and resource server. That means it is responsible for doing authorization as well as actually serving the resource, that's data or weather report or whatever. Then the protocol, and that is now kind of ratified a few days back, allows now MCP server to act only as a resource server, which is much more, that way you can use your enterprise, single sign-on, other mechanisms to get your tokens and grant, and then pass those grants on to as a resource server. So a lot of challenges, right? Is HTTP streaming HTTP good enough? Should WebSocket be supported? That's ongoing debate. How to deal with long-running tools, right? This is where it goes to like this A2A. It's a different spec called agent to agent by Google. And the question becomes like, why do you need A2A? Could MCP be enough, right? And there's a debate, and everybody has their opinion. But if MCP protocol were to add long-running task support, then A2A's need is a lot less reduced, right? So what is the issue right now? So right now, all the things I showed you, there's a general expectation that if I make a tool call, I get a response back in reasonable amount of time, like 5 seconds, 10 seconds, a minute, right? But what if that MCP server is actually backed by a human? So for example, you want to say, approve this invoice, and approval MCP server may end up sending an email to somebody, and that person will go click on something, look at, etc., and then say approve, and then MCP server can return response, right? This might take days, right? So what do you do in those situations, right? This is where now there's a support for kind of long running, like async support. So you kind of perhaps have a webhook that will say, okay, notify whenever you are done, and then the interaction may continue saying, okay, your invoice has been submitted, but approval is still pending, but you can meanwhile do blah, 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 right? Stuff like that. So this is the thing people mentioned, right? I think you mentioned, like, what if there are too many tools that you expose it to LLMs? LLMs get confused. In fact, Cursor just arbitrarily cuts your first 40 tools and saying these are the only tools you can use. And in fact, it allows only 5 MCP servers and total 40 tools or something like that. That's because, if you give like 1,000 tools to LLM doesn't know what to do, right? In fact, I was actually fixing my car, and I just asked the guy, like, how many tools do you have? And he kind of mentioned like 1,200 or something, if it's like, if I were to estimate it. Because if you think about it, like tire changing, that like all this, the different, everything requires like very many tools, right? So many screwdrivers, so many spanners, so many cleaning stuff, so many engine fixing things, and so on. But for a given task, you don't need all 1,200 tools. You need probably like dozen, because you're not fixing everything at once, right? You're doing one at a time. So what is that equivalent stuff in LLM world? And that's where some of the interesting things are coming. Like, like for example, can you do auto filtering of client side? Like based on the query, you're kind of going back to RAG world in a little bit, right? Saying, okay, I got this query related to picnic. I don't think stock market is important here in this particular context. So you'll just pass weather report, you'll probably pass your friends list and so on, but you won't pass like get stock market result. What do you mean by that? It's standard, right? LLM takes their whatever the time they take, and you are between your HTTP server will take. So it's all adds up. Yeah.
So when the client do the tool list, it's sent to the LM also, right? So
Yeah, the tool list, their description and input schema is sent along with your input initial prompt to the server. Yes.
so when you multiple so you have a hundred tools, you consume a lot of token, right?
Yep. Exactly. So you have to be very, very careful. There's that problem, right? One, LLMs get confused and you pay a lot of money for it, right? Because everything costs like token, description costs token. So then there's also a question like Exograph is used in production, and then one of the things that they had to worry about is like, okay, this LLM is generating lots of cute reports, but are they right? Right? Just because it says like the weather is good, it doesn't mean it is good, right? It just like it thinks it's good for because it may have found some keyword somewhere. So you need like testing and verification. And this is general problem. It's not specific to LLMs or MCP. Sorry, it's not specific to MCP, but any LLM based solution, agents, whatever. So you have to have like appropriate testing and verification to say, okay, like 90% of the queries will come back with certain keywords back or something, some sort of, and that's actually very open topic. Just to come back to this bit of this many tools problem, like GitHub has this dynamic tool selection. So GitHub has one MCP server and it has like 100 or so tools. So however, again, when you're doing something like, okay, hey, give me comments for this PR, you don't need to know all the issues and other things, right? You need to know only a few things. So you can sort of, based on your query, GitHub can filter it. And there are like several mechanisms available. Initially I mentioned like tools can, when I showed you the right away tools and just said open this close parenthesis. So there is extra field you can get called list changed. And that can be leveraged to kind of say, okay, now these are the tools. So MCP, rather than giving static set of tools, it can say, I will periodically tell you like what are the tools appropriate for a given task. So anyway, there's a lot of things to be done. I think I am just at time 8:10. I do have like 10-20 minutes. So if you have any questions, please do ask. Otherwise, I'm hanging out here. Go to exograph.dev. There is a GitHub link from there. Please start it. It does good to my ego. So, all right. Yeah.
So did you say you end up writing your own MCP server?
Yeah. So the question is, did I write my own MCP server? Actually, several of them, right? One is for Exograph as a data server. So where you can ask questions such as, what are the albums or what are the employees, and what is specific to that particular domain. So essentially Exograph is, you can think of as a meta MCP server, so it can help you write MCP servers. The second server I'm working on is MCP Exograph build server, which helps you to create Exograph models in the first place, such as create me Slack, or for example, one of the things I'm working on is what happened is recently people have started to use Exograph in a different way than I imagined. Initially, I imagined people will write code and then that's the model, and then model will produce database schema that Exograph generates and so on. But people wanted to say, I already got Postgres database, please just import it. And so we of course do that, but then people want to say, I also want access control, because that's the coolest thing in Exograph, right? If there's no access control, Exograph need not exist. You can just use SQL MCP server and that will be good enough. But because of access control, but then how do you do access control? Because that information isn't there, right? So we consult an LLM to say, what are the reasonable access control for this particular model? So that's another MCP server I'm working on. And then there's all these demos.
What is it? You use Java to write your code?
Oh no, actually, I used to be Java guy. I was actually, involved in Spring a lot, but these days I'm a Rust guy. I used to be after Java. I did a lot of Scala, and now these days I'm doing Rust. So Exograph is actually fairly large Rust projects, like 80,000 line of code, because it has to take care of all the things like code generation, SQL generation, access control, LSP server, and so on. Yeah.
This MCP server, is it possible to run an MCP server and then multiple clients can connect?
Yeah, absolutely. So, like for example, one of the person using Exograph, they have it in remotely available, and they have bunch of agencies using it, using Cloud desktop in this case, but they are working on their own client. But all those clients talk to the server over HTTP.
So you can specify to Cloud Desktop that uh, talk to this MCP server at this URL, I guess.
Absolutely, absolutely.
So
Yeah.
it doesn't have to start that MCP server.
No, no, no. So I showed the example. I showed, yes. I see where it's coming from. So the one I started, they were like local servers. The intern, of course, could talk to some remote server because that was used to be the protocol. Claude started to support HTTP very recently, like a month back. So now you can actually go. Earlier, people wrote a bridge. Even this client, you wrote a bridge in between. So that process will start on their server. That server, then that process will talk to the HTTP. So yeah. But now it's like streaming HTTP protocol is becoming very, very easily available. And so hopefully we won't have to do installing local servers ever.
You actually show the actual code for the client written in Java, right?
MCP server.
Um, the one you showed in Java.
Yeah, MCP server. This is MCP server.
But where is the client?
Oh, client is Cloud.
But what if I want to write the client?
Oh yeah, there is actually spec for that, right? This is in fact, it's just like, what is it doing is it's reading it and saying, so for example, what would happen in this case? It's going to say, I'm going to, let's suppose you will write your own client, chat client, right? So you will write your client, you will pass this to you using some API particular to your LLM, pass this information, and then you will look back, you will get back some response, right? That response could be, here's our answer, or that response could be invoke a tool, right? So in this case, it came and saying, oh, invoke a tool called get weather with this parameter. And then the client has to respond by actually invoking that tool and returning some response. In this case, it returned response that was like this. And now it takes that response and puts it back to the LLM as a part of conversation API or along with the original prompt. And then it will say, all right, I got the information. Then it will come back with this information, which you then just print it out. So actually, many people are writing MCP clients like that, because what happens is the Claude is fine, but it's not exactly the greatest experience, right? It's fine as a initial experience, and in fact, it does like some really, really cool stuff. It can do like it can draw. In fact, it can write JavaScript code to create React components, which will take the data, render it in the way you want. It's kind of amazing in some ways, scary in other ways. But that's not always the experience you want, because that JavaScript will have errors, and then Claude will fix it. But again, it's a common user will get confused what's going on here, right? So many people are writing their own MCP clients, and those MCP clients have a little bit specific nature. So for example, I talked about like testing and verifiability. So this particular customer, that Exograph customer, what they want to do is, whenever the response comes like this, they want to create links to all the interesting items. So for example, saying ad spending on this particular portfolio was so and so, and that ad spending on that particular portfolio becomes a link, so that they can click on it, and that goes to deterministic UI, like that's just a normal standard UI that says like, okay, if I'm trying to just get a vibe, like how are my products doing, then I might just like, yeah, that seems reasonable, okay, fine, move on. But if I want to act on like, oh my god, what is happening, why am I spending so much money, or why is it doing so badly, and I want to pull that money out of it or add some money, I kind of want to know, like, is it really telling me the truth? So they're writing the client that can look at the data and kind of like, fortify it with links and other things to point to their UI. So you can do all sorts of things there.
Yeah, so I look at different agent frameworks. They use when they talk to MCP server, they are writing the client code, right, to talk to them.
Yeah, exactly.
So, but if I want to call it from a Python, simple Python code, how do I do that?
Yeah. So
Reference I can follow.
yeah. So first of all, there are like there are SDKs available for Python and TypeScript and Rust and Java and everything. But you can write your own, because what like for example, if you are willing to do LLM specific calls, then you can take the MCP server's output, and that becomes tool description that you can pass into LLM. So you can do all sorts of pipe. That's in fact what is happening. The SDKs do that, right? Ultimately, so you can do that yourself. Yeah. Yeah. Last question. Yeah, exactly. So, an MC, remember the example I talked about, like where I wanted to use sampling. Alternative could have been like exograph server itself has itself act as a has its own LLM, right? And then it becomes agent, right? So agent, again, agent definition is all like, depending on who you talk to, but usually like in a fairly capable entity that can itself use AI to get some goal accomplished. So you can totally have a MCP server backed by LLM or backed by other MCP server. That's completely fine. That's exactly where the discussion comes. Like, do we need even A2A protocol, which is agent to agent? Because ultimately, what is agent, right? At some level, it's protocol. Still, you're still talking over HTTP or some sort of protocol saying do the following thing, right? And then what if that following thing is another MCP server, right? And then that itself can talk to more MCP servers and so on. So absolutely, yeah. Yeah, see, it's really interesting. Like, it's really depending on perspective, right? From client perspective, you're going to talk to one MCP server. From MCP server's perspective, the other MCP servers it acts as a client for those MCP servers. So it's sort of like they have both side, client side and the server side. So you kind of keep going on like that, right? So it's like does it act as a client or server? It can act as a both. That's to one side client, other side server. All right. Well, thank you very much. I'll be here for a few more minutes.